TU Delft is currently transitioning to being carbon neutral, climate adaptive and circular, whilst also realizing a biodiverse and livable campus. I see these as paramount challenges for the nearby future to establish a sustainable society. Carbon neutrality, climate adaptivity, circularity, biodiversity, quality of life. So I see circularity as an element of sustainability. But what does sustainability mean? The term sustainable is referring to something that can be continued without obstacles or limitations. South Africans use the term volhoubaar, which Dutch people immediately understand. Although to sustain was originally existing as a normal English verb, it got its strong present-day meaning through the UN committee led by Gro Harlem Brundtland, who introduced sustainable development as the desired future for humankind. A development that meets the needs of the present without compromising future generations to meet their needs. As Jon Christensen, one of my masters, put it, sustainable is everything future generations want to inherit, use and maintain. Sustainability includes a lot. John Elkington dissected the term sustainable in 3 parts: people, planet and profit, later replaced by prosperity. Nowadays, when we talk about sustainability, most people think of technical solutions. But as Elkington put it, it has a social, ecological and economical component. The first and the last should not be forgotten. Technical solutions are part of the ecological component. A big chunk of the technical aspect in ecological sustainability is related to essential flows: energy, water, materials, nutrients. And that brings me to circularity, because that essentially is the closing or continuation of cycles of resources: energy, water, materials and nutrients. Nowadays, in architectural debates, circular design seems to always refer to the use of building materials, but originally it includes more cycles. In fact, cycles of different resources can be interconnected. Waste materials and wastewater can become energy or nutrients, and water can become part of materials and food, which are nutrients. The so-called food, energy, water nexus presented by Andy Jenkins in this series demonstrates how circular systems can function in connection and synergy with each other. As the Ellen MacArthur Foundation presented it, circular systems are either finite. Metal, mineral and plastic material is used infinitely through reuse, repair, repurposing, remanufacturing or recycling, or bio-based material from biological origin, which should be grown and maintained in a sustainable manner so that they are replenished in a natural way. Both are good in the eyes of a circular designer, but plant-based materials generally cost less energy to produce and they bind carbon during growth. Reusing bio-based materials, instead of felling a new range of trees, will help to get a positive carbon balance, meaning that there is more carbon dioxide absorbed than emitted. In this example, it becomes clear how circularity links in with climate action. Urban mining is a form of the circular technical cycle. In this case, valuable materials are reclaimed from buildings and other products, in order to reprocess them into new products or buildings. A little different from recycling, because the latter usually refers to reprocessing of the same resource, whereas urban mining deals with a complex product, and a building is one of those, from which potentially many valuable resources are drawn. Other forms of circularity in the built environment deal with products as a service. Deposit systems and arrangements with suppliers and manufacturers, who remain the owners, take back old products and reprocess them. I think this should be the norm in the near future. Companies remaining responsible for their products and having to reprocess these themselves. This will naturally lead to a circular economy. The final example I want to give connects circularity again with a wider set of sustainability goals. The question of renovation or transformation versus demolition and new construction. When confronted with an old building that no longer complies with modern demands or desires, a tendency has been to demolish and replace it with a sustainable new building. Possibly energy neutral, possibly built in a circular way. However, Directly reusing the old building and then restoring, renovating or transforming it generally leads to a much smaller use of virgin materials, to much less energy use and subsequently smaller carbon emissions. In this case, it is not the way of constructing or renovating that is most impactful, but the decision to retrofit or construct anew.